Good morning, everyone. So today we're going to go over some design rules that you need to consider for 3D printing. This is actually going to be the first of two separate videos because there's a lot to get through. Now, I'm going to look at this chart. A few things I want to point out here is that at the top, we have different design considerations we're going to talk about. And over here on the left, we have different 3D printing technologies. We at school have what's called FDM, or Fused Deposition Modeling Printers. So we only need to pay attention to this first row. You can ignore everything below that. You also want to remember that our printers have a nozzle diameter of 0.4 millimeters, which is important. We're going to sort of come back to that as we talk about this. So to get going here, the first two are looking at supported and unsupported walls. And what that basically means, if you have any part of your design that's sort of, kind of like a wall shape or just really any part of your design, you really want the thickness to be at least 0.8 millimeters, if not thicker. So again, if the diameter of the nozzle of our printer is 0.4, this basically means that these are going to be 2 layers thick, which should be like the absolute minimum. You're probably going to want something at least 1 millimeter, 2 millimeters thick, but this is like the minimum you need. Now, if you were to try and print something between 0.4 and 0.8, it's only going to be 1 layer thick, which is going to be very fragile. And if you tried to print something that was less than 0.4 millimeters thick, it won't even print at all because it's actually less than the diameter of the nozzle, and it just won't print. It'll just disappear. We're going to come back to support and overhangs in the next video. That's probably the most important topic. Embossed and engraved details. This basically means that oftentimes you may want to put something where you have a part sort of like either engraved, like cut out into the model, or something sort of sticking out of the model. A classic example of this, if you want to have like a logo, if you want to put your name on something, sometimes you want your name to be sort of sticking out. Sometimes you want the name to be sort of dug into the model. And it doesn't really matter which one you prefer. Same sort of rules apply. You want it to be, each element to be at least 0.6 millimeters wide and at least 2 millimeters high. And if you have something less than this, especially if you're doing like text, like your name, the letters just won't come out that well. So it's, pay attention to these measurements to make sure it prints the way you want. We'll come back to horizontal bridging because that is related to this one over here. If you have any sort of a hole in your design, the minimum diameter that they recommend is 2 millimeters, if not larger. So the minimum is 2 millimeters. Anything that you want to have sort of connecting and moving parts, it's recommended that you have at least 0.5 millimeter difference for clearance. So if you have, for example, like a peg and a hole, if you want these two to be able to move, the diameter of the hole should be at least 0.5 millimeters bigger than the actual peg. The escape hole doesn't really matter to us. That's related to other technologies, so you can sort of not worry about that. This one here is looking at the minimum features. So it's sort of a good rule of thumb for any sort of feature as part of your design. You want to be at least 2 millimeters thick. So whether that be like, like a phone case or really anything, like 2 millimeters is actually pretty thin as it is. That really should be like the minimum thickness of anything that you make. Anything less than that, it's just not going to be a very durable product. Over here, pin diameter. So if you need any sort of like a pin as part of your design, it's recommended that the minimum diameter of that pin be 3 millimeters. Otherwise, it's going to be, again, not durable enough. It's going to be sort of kind of bendy, get kind of warped. So at least 3 millimeters for diameter. For example, if you're making like a 3D printed car, and that would be like the axle, that'd be sort of an example of that. This one is incredibly important, tolerance. So our 3D printers, they're great printers. They cost about $1,000. However, in the world of 3D printers, some of the professional ones can cost over $100,000. So these are still considered hobby printers. They are not perfectly accurate. So as it says, there's about a 0.5% plus or minus tolerance when it comes to your designs. So if you make something and you have the diameter of the hole be exactly 5 millimeters, the hole may not be perfectly 5 millimeters. And one case where this comes into play is if you have any sort of a peg that goes into a hole, holes are often printed just a tiny bit smaller. So if you have like a 1 millimeter peg and a 1 millimeter hole, that peg will definitely not fit inside the hole. You need to make the holes a little bit larger in order to accommodate for that.